two fixed point charges plus 4e and e are separated by distance of a unit, where should a third point charge be placed relative to 4e charge for it to be in equilibrium? Are there cases wherein we get the same stable and unstable equilibrium? So first thing first, I would like to draw a diagram. So we have the charges. So this is 4e and this is e. If I consider this as the origin, this is the origin, this is a units away. And now we have a third charge called x, which is, well, we can call it as d units away. Right? And we have to make this stable, is it not? So we'll start off with let d be the distance of the third charge from 4e. Now, the free body diagram of third charge. Right? So we are looking at two forces. Force on third charge, let's call it as x, right? We call it as x because of 4e. And since we are looking at equilibrium, so the forces has to be equal. So the lengths are equal over here, x by e. So it's given that fxe is equal to fx4e, right? And by Coulomb's law, we have the force between charges as q1 q2 by r square. Now the working, so substituting in this particular expression, so that would be k times of, in this case, x into e by r is, in this case, what is r? Oh yeah, between x and e, the distance would be what? A minus d, is it not? A minus d, the whole square, and that equals to k times of x into 4e by d square, right? So k4e, sorry, kxe and kxe are common. We just have to solve this. So we have to find d in terms of a bit of rearranging, a minus d the whole square, which is equal to d square, taking root both the sides. So we'll end up with plus or minus a minus d, which is equal to d. So first possibility is that we have a, or we have to find d, right? Plus or minus 2a, or we'll take plus 2a minus 2d is equal to d. This is case 1. So a bit of rearranging, and d will be equal to 2a by 3. Case 2, minus 2a plus 2d is equal to d, right? And if we transpose and all of that, 2a will be equal to minus d. So d is equal to a, 2a. Okay, guys. Is there something? No. Minus plus, and then that is negative. Okay. Now, so 2a will be where? 2a will be somewhere over here, and 2a by 3 will be somewhere in between. The additional question is that, are there cases wherein we see stable and unstable? So at this 2 point, we mathematically we got it to be point wherein it will be at equilibrium. Right? Is this possible? Think about it. No, right? At 2a, we have the forces, right, at 2a. 2a is somewhere over here. We have both the forces to be, pointing towards the right. There's no way that will be stable. At 2a, we have both our net force to be net force to be to the right. Thus, it cannot be a point of equilibrium. While at 2a by 3, which is in between the points, is it not? It's somewhere in between, somewhere over here actually. That makes sense. We have the forces acting in opposite direction. Thus, we have a stable equilibrium actually. Is it stable or unstable? So is it stable or unstable? If I push this left or right, what happens? Yes, there will be a lot more force from either of the discharges, and they'll push it back to the original equilibrium point. So at 2a by 3, we have a stable equilibrium as the net force will be pointing to 2a by 3 actually, or I can just write that only. Pointing to equilibrium point, that is 2a by 3, on a small displacement. Right, that's how you check if they are stable or unstable equilibrium, is it not? Right? If I push this a bit left or right, well, actually with calculation we got to find that it'll be somewhere over here. But anyways, according to diagram, I let it be over here. Let us not make it wrong. You guys will be copying. So if I push it a bit to the right, what happens? This particular charge will have a lot more push towards the left. The net force will be to the left, so it will come back. If I push this to the right, what happens? 4e will have a lot more push to the right, is it not? If I push this to the left, 4e will have a lot more force to the right, and so again it will push it back. So we have a scenario wherein it is at stable equilibrium. And the other point 2a, it cannot be the case because both are pointing towards the right. The math, got us that answer, but well, it's not a scenario which will give us any kind of equilibrium. Okay guys, because both the charges are positive, that is either they are like nature charges, so either they will repel or attract when we keep it over here, right, which is not within the space. If they were of different nature charges, then things would have been different, but not in this case. Okay, so here the main funda is that we have the distance d and a minus d. That is one thing that you guys have to be careful about, and everything else is simple simplification. And post simplification, this is where you guys can go wrong, right? Checking out if it's stable or unstable. Right? If not, pretty much everything else is quite simple.